So we'll continue from where we ended last time. Last time we were able to set up these two equations. So we're trying to find both the location and then the scale parameter, that is both mu and sigma. So we used the standard normal to set up this already. So we'll proceed to learn how to solve these two equations. And so to continue, we can see that this can be written as 2 minus mu equals negative 0.674 sigma. And then it can be written as mu plus 0.674. We could write it as mu minus 0.674 sigma equals 2. And then we could also simplify this to be 8 minus mu equals 1.287. I just multiplied both sides by sigma. And so it means that this can also be simplified as mu plus 1.287 sigma equals 8. So this is equation 1. This is equation 2. Mu plus 1.287 sigma equals 8. So now all that we have to do is to be able to solve for sigma. How do we solve for sigma? So, or how do we solve for the parameters? We want to use elimination method. Now this is algebra. We want to use elimination method to eliminate one of them. So I could say that equation 2 minus equation 1. So if I do equation 2 minus equation 1, I will get mu minus mu. That should give you 0. And then we have 1.287 sigma minus 0.674 sigma equals 8 minus 2. So I said equation 2 minus equation 1, mu minus mu, which is this one. This minus, remember this is negative here already. That is why it's written this way. And then 8 minus 2 that way. Mu minus mu gives you 0. This minus this becomes plus. So this gives us 1.287 sigma plus 0.674 sigma equals 8 minus 2 gives us 6. So it means that if we add this to this, when you add them, what do you get? 1.287 plus 0.674. When you add them, so it is like adding 2x plus x. It gives you 3x. It is the same idea here. This sigma here is just a variable. Is that okay? And so then this gives you 1.956 sigma equals 6. Now let's solve for sigma. So to solve for sigma, remember we had 1.956 sigma equals 6. To solve for sigma, Sigma equals 6 divided by 1.956. And then this should give you sigma to be 3.067. So when we have sigma to be this, I could say, well, now plug in sigma equals 3.067 into equation 1. So when we come to equation 1, wherever, this is equation 1, wherever we say sigma, we plug in that answer here. Remember, equation 1 is what? Mu minus 0.674 sigma equals 2. This is equation 1. And I'm plugging this guy here. So I'm going to get mu minus 0.674. Now there is sigma here. So wherever we say sigma, we put this value there. This gives us 3.067 equals 2. And then we just have to be able to solve for mu. So mu, so what is this times that? What do you get? Points. So 0.674 times 3.067. That gives us 2.0. So this gives you minus 2.0671 equals 2. So we can see mu equals 2 plus 2.0671. So mu equals 4.0671. So this is how to solve for both when you don't have location and then scale, when you don't have, when the mu and then the standard deviations are unknown. So we learned last week how to set up this equation. So you could be able to look at last week videos or look at last week notes. And then when you set up the equations, we have to be able to solve the equations to get the unknowns. So that is what we have gotten here. So we see that the mean is 4.0671, and then the standard deviation is 3.067. So that is it for that one. Today, we want to, most of our stuff would be from StatCrunch. We are going to learn how to describe various distributions of data. So I want you to open StatCrunch and then load this data set. By the way, don't forget to check your attendance. That is the password on the board. So I want you to open StatCrunch and then load this data set. So I have my StatCrunch, and then to load the data set, I go to data, load, then we go to shared data sets, and then the data is, I think it's CH5 or so. Yes. So it is this data set, the one with Susie and Hall. So we click on that one here. Have we all been able to load a data set? Is anybody having challenges in loading a data set? Okay. Since everybody has been able to load a data set. So first, let's look at the data set here. You see, we have various columns. So these are just randomly generated data sets. So we have normal, we have short-tailed, we have long-tailed, right skewed, and then left skewed. You can see that. Is that okay? So let's learn to plot the histogram for all of them. So let's start with we want to describe the shape. So let's start with the histogram for the normal. So now I want you to plot the histogram for the normal. So we know that for normal, our histogram should be like bell-shaped. So let's try to plot that. So we go to graph, and then we go to histogram, and then I select normal for the column, and then I hit compute. My interface is a bit different from yours because I'm using the iPad. Is that okay? But I think your computer, it should be just a drop down. So, and then we hit compute. So this is the histogram. Is that okay? So now let's try to be able to get the shape. So you can see, even though this is not perfect because the data are randomly generated, but you can see this is looking like a bell shaped. So you can see, so this is looking like a bell shape here. So let's go and then describe that one. So we see the shape of the histogram for the normal is looking like a bell shape. So we can see, is that okay? Now that you know this, I want you to be able to fill in that column for the rest of them. So now let's go do the short tail distribution. So let's go do that one and start crunch. So we have start crunch here. To be able to go to that one, you don't need to do hold everything again. Let's go to options. Let's go to edit, right? When you go to edit, instead of selecting the normal, let's select the short tailed. And then let me ignore the normal. So we click on the short tail and then let's hit compute. What do we see? We can see that it's mostly flat at the top. Is that okay? So it's looking like a box, isn't it? Because look at this one here, straight here and like that. So it's looking like it because it's flat at the top and then here. So it's like a box. So we can see the distribution for that one is looking like this. Right? It's not that perfect because I know that the length of this, but we are just trying to give like approximate. We can see the key thing is that you can see that on top it's flat. Is that okay? Good. Now let's go to the long tail. So we don't need to, we just go to options or yours is edit, edit, and then let's choose long tail. And then let's hit compute. You see the long tail. You see the peak is in the middle. So it looks like this. Look at how the long tail looks like. So you can see the long tail is looking like this. Do you see that? Okay. Any questions on what we've done so far? Okay. Now let's proceed to the right skewed and then the left skewed. Same thing, options, edit. My interface is different from yours because but yours should be easier than mine. And then I go to the right skewed. We hit the compute. You see how the right skewed looks like. You see the tail is to the right. So, and then it means that the right skewed is like this. And then let's go and do that for the left skewed. We go to edit and then you choose left skewed. And then we hit compute. You see the left skewed, the tail is to the left. Is that okay? You can see these are key things that you should be able to see and tell straight away. Is that okay? So the left skewed. So the left skewed is like the opposite of the right skewed. So it's like this. Any questions so far? Okay. And then the difference between the short tail and the long tail, you see the short tail is mostly flat at the top, but the long tail, most of them, the data are in the middle, and then the tails are long. Is that okay? So, okay. Now that we know this, I want you, now let's turn our attention to the box plots. Is that okay? So let's go construct the box plot for the normal. So I close my histogram, and then box plot, I go to graph, and then you see box plots. And then I select for the normal. And then I hit compute. Now, this box plot here, because the data are randomly generated, it's not really giving the true picture of the normal distribution. This is the reason. The reason is because I expect that this median should be in the middle. Is that okay? But it's not perfect. But so we are just trying to show it's like a hypothetical situation. So the data is not perfect, but then again, we expect that this thing here should be in the middle. Is that okay? Good. The other thing we can also see is that we are not seeing any outliers, right? And so you can also see that the length of this tail here and then this one here, they are almost the same. Can you see that? Okay, so now let's go and then describe the box plot for the normal. So it looks like, okay, even if we want to do that, let's try to see edit. And then let me draw the box plot horizontally. So it looks like this. We expect for the normal should look like this. This should be in the middle. And then there you go. Is that okay? Let's go and then draw that of the short tail. So for the short tail, let's come to options, edit, and then change from the normal to the short tail. And then hit compute. What can you see about the short tail? You see the box where the interquartile range, you see that it's fatter. Can you see that? Is that okay? Okay. So we can see that for the short tail, it looks like so it looks like this. Is that okay? Now let's go do that for the long tail. I go to options, edit. I go to long tail, and then I hit compute. You see the long tail, look at how it's looking like. The interquartile range is very thin, right? So these are some of the things when you see, you should be able to tell, oh, this could be long tail, this could be short tail. Is that okay? So it looks like this, right? And then let's get to the skewed right and then the skewed left. Then we hit compute. So you see the way the skewed right is. You see the tail is longer to the right. Can you see that? For skewed right, the tail is what? Longer to the right. Is that okay? And look at where the median is. And so we could see that for the skewed right, it's going to look like this. And then here is what? Longer. Do we see that? Let's get to the skewed left. So for skewed left, you see for the other one, the tail is longer at the left side. So looks like this, like that. Any questions so far? So anytime you see this box plot, oh, the tail is longer to the left, should be able to tell this is what's skewed to the left. Is that okay? The tail is longer to the right. If the length of the tail is the same and then the median is in the middle, oh, it's symmetric. That kind of thing. Right. Any questions so far? Okay. The next thing we want to do is we are going to construct the QQ plots and make some comments. Is that okay? So now let's go and then construct the QQ plots. So we are going to repeat the same thing for the normal and all the distributions. So let's get to that. So to get the QQ plot, we close this one here. We go to graph, and then can you see QQ plot in the drop-down menus? Yes, good. So then you click on that one. Okay. And then we'll click on the normal. And then we hit compute. So usually in statistics, not at this level, I just want to show you the essence of the QQ plots. So usually in statistics, this QQ plot, they are diagnostic tools. They help us to be able to know what distribution our data is following. Is that okay? Does that make sense? And so if, for example, you see here is a normal quantile. So it looks like it has assumed the normal distribution. So if it's following the normal distribution, most of the data points would lie on the red line here you see. Is that okay? So usually as a statistician, if I want to be able to say, oh, this data is following normal distribution, log normal, there are so many distributions, I don't want to go into details, but I just want to let you know that we use this QQ plus to be able to tell. And it also helps us to be able to identify outliers. You see, when you get on the distribution, some of them are very far from this line. That gives you an idea that they are what outliers. Is that okay? But for now, what can you say about this one? So you can see most of the data points, they are very close to the red line. Do you see that for the normal? Does that make sense? Okay. So then let's go draw that. So we have, let me change color. And then it looks like that. My drawing is not perfect, but I'm just trying to show that most of the data are close to the red line. Is that okay? So what should be our comment? The pattern we can see is that the dots are on the line or very close to the line. Does that make sense? Okay. Let's go do that for the short tail. So I go to options, edit, and then I choose short tail, and then I hit compute. So when you look at the short tail, look at the pattern we are having. You see at the beginning, so look at this red line here. So looking at this red line here, when we come to the bottom tail here, we can see that the data, they are above the red line. Do you see that? Here, they are above the red line. And then they are below, very close, above, and then below. Is that okay? So now that you have this, I want you to be able to make that sketch on your slides. Make that sketch and then try to comment. So you can see here, it's high. I use the term high because when the data points are above the red line, they are high. Is that okay? When they are below the red line here, they are low. So you see high, low, very close, high, low. Is that okay? So now let's go and then fill in that one. So we can see we have something like if this is the red line, what do we have? We have high. Let's look at them again. Okay. So we have high, low, high, low. Let's see. Yeah. So we see we have the pattern, we have high, low, high, low. Right. Then now you should be able to do that for the long tail. So go and then do that for the long tail and then make your comments. So for the long tail, we come edit long tail. We hit compute. Oh, for the long tail, it's even obvious for you to see. You see these two data points here. Very clear that they are outliers. You see, they are very far from the red line. Can you see that? Good. So then you can see. So this is looking like. So you see, we look at this one too. There's one at the bottom here. Can you see that? So that also tells you it's an outlier. You see the essence of the QQ plot? Yeah. So let's try to do that. So we have, and then it's going to be, oh, let me bring this line up a bit. Good. Then I have something like this. Something like that. Let's see. Yeah, you see. So low, high, low, high, right? Good. So we have low, high, low, high. And then let's do that for the right tail. Right skewed. Options, edit, right skewed. And then I hit compute. So what do you see? It's giving like a U, right? So this is what high, and then low, and then high. So Um, it's looking like this, something like that. So we have high, low, high. Let's go confirm. Right. And then let's finish with our last one, which is the left skewed. Let's go to start crunch, go to options, edit, and then compute. So this is also giving like an N. You see, some of the data points are very low. Look at where the -2 is. That should tell you those ones are outliers, right? So this is low, high, low. So it's giving like an N. So we have, so what can we say? We can see low, high, low. Any questions on this? So the essence of you knowing this is that your responsibility is to be able to see and then make a good guess. Is that okay? And there are some distributions I feel that you should be able to make the guess right away, especially when it comes to the skewed right and then the skewed left. Their histograms are very obvious. Is that okay? If it's skewed right, you see the tail is to the right, and then most of the data points are at the left. If it's skewed left, look at what the histogram looks like. Is that okay? If it's normal, it's a bell shaped. And also their box plots too are very easy to see. When it's skewed right, look at where the tail is. The tail is longer to the right side. If it's skewed left, the tail is longer to the left side. If it's normal, you see both of the tails, they are even. Is that okay? You could also use the the interquartile range boxes to also see. And though for the long tail, it's also easier to see when you see the box plot. The box was very small. It should also be easier for you to see. Is that okay? Any other questions? Okay. If you have no questions,